When we're thinking about Hadoop, it's important to understand how new the ecosystem is. The initial release of the open source product was in 2007, but the first stable release wasn't until 2011. So as of this recording, that's only a couple of years. And it is important to understand that the open source contributions are driving the new libraries and features of Hadoop. The most major releases were in 2013, release 2.2, where MapReduce 2 Yarn, yet another resource negotiator, was introduced, and 2.4 a year later, in the middle of 2014, where a number of important and asked for enterprise features, such as rolling updates, ACLs or access control lists for security, full support for HTTPS, and automatic failover, were released in a stable release for the Hadoop ecosystem. Another consideration when working with Hadoop in a production environment is whether or not you want to work on a cloud. Now, I'm just picking the most popular. There are other clouds implementations out there, but these are the ones that I've just personally used. And what they are is they are clusters of virtual machines or partially managed distributions. So to be clear, when you're picking a cloud-based implementation, for example on Amazon's cloud, you could just set up a number of EC2 or Elastic Compute 2 virtual machines and install a Hadoop distribution onto them and then configure them and then run it yourself. But the majority of the customers that I work with use the cloud so that they don't have to do all that management themselves. So to that end, both Amazon and Microsoft have these two popular implementations of partially managed Hadoop clusters. Amazon's is called EMR, or Elastic MapReduce, and Microsoft's is called HD Insight. Now let's take a look at Hadoop implementations on various clouds. And we're going to start with Amazon Web Services. And as I mentioned in the previous movie, there's really two ways to do this. You could run your own servers on EC2 and just install the Hadoop distributions on Linux servers and manage them yourself. Now, if you wanted to do that and you're unfamiliar with EC2, there's two courses on lynda.com that you could take a look at to become more familiar. Those are the Up and Running or the Essentials training for AWS. We're going to go, however, to the EMR or the Managed Hadoop Framework implementation, which, as we'll see when we get into it, does use EC2 instances with the Hadoop binaries installed, but Amazon provides quite a bit of management, and this is what I find with my customers that's used more commonly. So I'm going to go ahead and click on that to get started. And you'll notice that there are 3 steps. You are going to be working initially with your data out of the S3 file system in Amazon, and then you can choose to do MapReduce directly against S3, or you can upload your data from S3 into the HDFS file system that's part of your EC2 instances. Then you're going to create your cluster, which will be n number of EC2 instances with the JVMs with the Hadoop daemons installed on them, and then you're going to execute your jobs. Now, if this sounds pretty intimidating, there are some samples that you can work with, and I suggest that you do to kind of get a sense of how this flow goes. Another consideration when you're working with Amazon is that although if you're a new customer, they'll give you a free tier to try out some of their services, EMR is not included in that free tier, and it's really important if you try it out that you remember to turn it off, because you can incur a very large bill if you are just testing and you forget to turn it off. So don't say you weren't warned. So I'm going to go ahead and say create cluster, and I'm going to call this test lin, and I can enable termination protection, which means the job is done. I can just shut off these EC2 machines and delete them or not. Okay. I can also set up logging, and if I want to log, I have to specify an S3 location, because again, this is really the file system of Amazon, and I can turn off or on debugging. Now notice if I scroll down, this is where we get into the distributions. So the AWS EMR supports the Amazon distributions that are open source, and you can see here's the various Hadoop versions, and they've got 2.4 with some subversions, or 2.2 or Hadoop 1.0, or they have the MapR distribution. In addition to the distribution that you select, by default certain libraries are installed. So Hive and Pig and Hue are installed, and you can install additional libraries. Now if I set this to Hadoop 1, you can see that it's warning me that some of these libraries are not available. And I click here and I have very few libraries. If I set it to Hadoop 2, I'm going to have a couple more libraries. And if I set it to Hadoop 2.4, then I'm going to have all the newest libraries that are supported on this distribution. Now if I switch to MapR, then I have to pick an edition, and then again notice that some of the libraries aren't available. So I mentioned in previous movies, but you can kind of see how it works here, that you need to, when you're planning your Hadoop production distribution, figure out which libraries you need, which libraries you feel comfortable with in terms of their maturity, and then pick your distribution. So I'm going to just go ahead and switch back here and show you this one, and then I'm going to go down and show you a few more settings. So you can set up encryption here, and then here's where you set your EC2 instances. And by default, you can use up to 20 instances. So you'll notice here's where you configure your JVM daemons. So you have a master server, then you have core and task servers. The master server assigns tasks to the task nodes. They're also sometimes called the slave nodes. Now, what's interesting in Amazon is that you have by default one master and 2 cores and 0 tasks. This box right here can save you a whole lot of money in a production situation. This is a very interesting part of working with Amazon Web Services. Their pricing model includes this capability called spot pricing. And what this is this allows you to, and I'll just check spot so you can see, to bid for different sizes of machines. And I can put in, this is an hourly bid here. So I can put in that I want to pay 5 cents an hour, because Amazon bills hourly, for this particular machine size. Now where this comes particularly usefully into play with Hadoop is when you have these batch processes that should run, but they don't have a particular schedule. Because the way that Amazon spot pricing works is if there's unused capacity, then you're going to get this great price, which is probably as much as 1/10, 1/20th, even 1/50th of the regular price. So you can save a lot of money. But if there's no unused capacity, you won't get your job running. So these are for jobs that you have some flexibility around when you can run. I liken it to if you are bidding last minute for a cheap flight, maybe to Hawaii, and you want to go on vacation and you have flexibility in time and you're trying to hit a certain budget. It's very, very similar. This is commonly used for batch processing for behavioral data that is nice to have, but not essential. So it's a tip that I've worked with the Amazon distribution. And you can see you pick the different type of machine here. And when you get into the really big machines, these extra larges, you can save a lot of money. And then if the job runs because you have unused compute, you'll have a quick run of the job and you'll have a very, very reasonable cost. So it's just a tip. So then you just set your security, your bootstrap, and your various action steps. Now this is a lot to configure, so what Amazon has here is to configure a sample application. So what are these sample applications? So notice if we click here, we have 4 samples, and they have to do with behavioral data. The first one is advertising information. The next one is the hello world of Hadoop, which is called word count, and we'll be going into that in quite a bit more detail in a subsequent movie. Then we have 2 log analyzers. And notice this one right here, the CloudFront HTTP log analyzer, is a custom jar or Java file. This is written in Java, and it's a MapReduce job. And the Apache log reports are using a pig script. So it's interesting to see this mixing of languages. These 2 samples are in Java, and Hive, of course, we saw in previous movies, HQL, and pig is a script-like language. I guess it's kind of like a batch processing language or a PowerShell if you come from the Windows community. Notice also that you have to interact with S3 here. So if I click right here, it's going to actually go out to my S3 directories, and I can pick a file that I want to input. So again, as I said in a previous movie, when you install HDFS and work with Hadoop on-premise, you really don't have this kind of abstraction with the file system. But when you're working with a cloud-based implementation, it's very, very common that you're going to first start with the cloud-based file system, and then you're going to move the files from the cloud-based file system through the Hadoop processes. And then, as you'll see, the output actually goes, I need to There, we need to set the output. The output actually goes back out. Let's see if I can go there. To S3. So it's S3 as a source, Hadoop as the processing engine with the EC2 instances, and S3 as output. And then I click OK. And then what I would do is I would just accept all the defaults, and I would click Create Cluster. And literally, it's a 1 or 2 click activity if you understand all of the inputs. So what's happening here in Amazon is literally we have EC2 instances spinning up that are Amazon machine images, and they have the Hadoop binaries installed on them. And once the cluster spins up, I believe I had one master and a couple of slave nodes here, if I remember correctly, then this particular job will run. Now, we didn't actually see the text of the job, and it'll run against this information, and then it'll process it and dump the results back out into S3. You can see, if I click on monitoring, that I have extensive monitoring capability, because this is designed as, I call it a data dump truck in a way. Dump your data in, do the processing, and send it out down the chute. So you can see the status of the cluster. And all the stuff that you can see on the Amazon site, you can also programmatically capture. So if you have some sort of monitoring application that either you purchase or you write, because there are APIs against all this kind of stuff, you can monitor this in whatever application you have. Amazon also has a mobile application, so you can monitor this actually from your phone, which is kind of amazing. And then you can look at the node status, again, all kinds of stuff, because the idea in AMR stands for MapReduce. So the idea here is that you're running these big batch jobs across many, many, many commodity computers, and you're monitoring to see how long do they take, are they done, when can I get my output, because it's not an interactive type of a situation. Now if I go back over here to EC2, there my instances are spinning up. So it's interesting to understand the interaction in the Amazon console, that I didn't spin up any instances in EC2 per se, but yet I can take a look at them, because what the EMR did is they turned on AMIs, or Amazon Machine Images, that have Hadoop on them and associated them and allow me to run jobs through them. So that's a quick introduction to working with Amazon Web Services and Hadoop. Now let's take a look at Microsoft Azure and Hadoop. To do this, we can look at Azure Virtual Machines. It's the same type of implementation. If you'd like to learn more about working with Azure Virtual Machines, go ahead and take a look at the lynda.com course, Up and Running with Azure. So we're going to take a look at the managed implementation, which is called HDInsight. And this is similar to, but not identical to, the AWS EMR. So I'm going to click here to create an HDInsight cluster. And you can see, here are the libraries that I have available: Hadoop, hbase, and something called Storm. So inside of here, I'm just going to call this lynda, and see the name is available. And I have 4 data nodes, and I can go up to 32 here. And then I have admin as my cluster username. And I'm going to put in a password and make sure I type the same password. And this associates with the storage account. Now what is a storage account? This is analogous to the AWS S3. This is an Azure file system or an Azure blob. And I can create a new container inside of here, or I can work with an existing one. So I'm going to work with this one, and then I'm going to create the cluster. And again, just like in Amazon, what's happening here is the Azure infrastructure is allocating a number of Azure virtual machines that have images of the Hadoop binaries. Now, by default, the Microsoft implementation does not run on Linux, it runs on Windows. And this is an important implementation detail, because as more and more enterprises decide that they want to work with Hadoop, there sometimes is not the situation in those enterprises of having a Linux admin. So sometimes from a practical point, it works better for them to have a Hadoop implementation on the more familiar Windows. So this will take a minute or two to spin up. So we're going to pause the video and come back once this is completed. So now that we have our Hadoop cluster, we're going to take a look at it. So I'm going to click into it. And you see I have a very friendly kind of a dashboard here. and you can see it's linked to my storage account, and it tells me how many more cores I have to work with. And you can see there's my cluster connection string. And I have 4 data nodes and 2 head nodes. I can look at the resource usage over various periods of time, and I can look at the configuration. Now, this, you might wonder, this looks great, but how do I actually query this thing? And if you look at the bottom here, you'll notice I have a query console. And Microsoft provides its users with a very friendly interface to get started. This is somewhat similar to the Cloudera Hue graphical editor, but they provide you with a lot of useful samples. And you can see here we've got a Hive editor, a job history, and a file browser. So kind of similar, but the examples I find to be a lot more useful than the simplistic examples in the Cloudera example. So again, so I'm taking the time to show you this. So you can see that you have a log analytics. You might remember there was a similar one in Amazon. And here's an interesting one, sensor data analysis. So I'm actually going to click on this one because this is kind of a hot topic now with the Internet of Things and sensors collecting all kinds of data. And here they give you a tutorial, which I'm not going to take the time to go through, but you can see how the interaction goes, which I think is really important. So you can see the sensor data is loaded into Windows Azure Storage Blob, and then you create Hive tables on top of the blob storage so that you can run MapReduce processes across them, which are abstracted away with Hive queries, which you'll remember from previous movie are SQL-like queries. Then you'll run those queries, and then Microsoft leverages its ecosystem by having you load the resultant data into Excel and then visualizing it. It's really kind of interesting, their implementation. You really don't see the words MapReduce here anywhere because they're abstracted away from you. And I think it is important to understand kind of what's going on under the hood, because when you're working with these samples, of course, you've got really small amounts of data. And a practical consideration when you work with Hadoop in the real world is around very, very large amounts of data. So having an understanding of the type of MapReduce information that's being produced by Hive is key to successfully working with a Hadoop implementation. And if I click and I take a look at the Hive editor here, I can give my query a name, and I have a sample here. And again, it looks very simplistic SQL, and I go ahead and I click Submit, and I'm submitting it to the cluster. And you might remember in the earlier demonstration, I showed in the Hue editor for Cloudera. It was kind of similar. The difference here is we're not seeing the log information quite as quickly coming back, although it looks like it's starting. And this, of course, will be creating a set of MapReduce jobs. I'm going to go ahead and click on the job history, and you can see it shows that the job is running. Again, a big part of working with actual production MapReduce workflows is monitoring the job statuses, because it is common that when you're initially setting them up, they will time out, they may not work properly, because again, you've got the dump truck for data here. You're dumping in all that behavioral data, you're trying to get meaning out of it. So let's click into the query again, and you can see here we have the output. So it's just a list. Were you surprised at how long it took for the select star to return? Again, I want to remind you that even though we're using abstraction layers, the underlying framework is MapReduce. And you can see here's the jar file, which is a Java file. This is creating this lower level implementation for you with the higher level library. Again, I know I've said this a couple times in this course, but it's really important in dealing with the Hadoop ecosystem that you understand what type of activity you want to do and what type of library you want to work with.